right? Yep. And we'll start with an intermezzo from Bill. Hi, Bill. Hello. Hello all. This is Bill, and I'm afraid that I'll need to change the assignment. Sorry, but the mayor came along, and he really wanted to change straight to processing. So we'll change the requirements. The first part you already know about, and the second part I'll have to expand. And that's the expansion in those two lines over there. So first of all, the permit system will have an automatic approval if the height of the building is between 3 and 5 meters. Right? Jot that down. Really good. Yes, you're jotting it down. Great, great. You all need to jot that down, of course. And if not, of course, an approval by a approver. Right. And the second change in the requirement will be that to expand the permit system with an email, message, sorry, we're not using emails, we're making it messages, message, sent to the requester, informing him of the result, approved or not. I'm pretty sure that this is already in it. Yes. Okay, great. Just one extra requirement then. Right. So between 3 and 5 meters. Thank you, Edwin. Thank you, Bill. So that was Bill. He just popped in, and he has changed the requirements. Right. So this is something I will verify tomorrow, this change in requirements in your assignment. So that's a change on the assignment part 1 and 2, and I'll add an assignment for testing this as well. Next slide. All right, so of course you needed to remember what Bill just said. But now we're focusing on testing it and linking it to requirement specification, process, and logical data model. Now, this was something from the first lecture, right? So perhaps this would be harder to answer for those that did not attend the first lecture. But try anyway, okay? So, requirements in terms of SPADE, those are those titles in the beginning. Right, just the titles. And the specifications in terms of SPADE are where the titles become evident, using the title name, then the equal sign, and then the specification. This is all clear, you already saw that, right? So that's the specification part. And then the process is something that SPADE creates for you. Now normally, in terms of managing the software project that you are managing, requirements and specifications are very important because those are the contractual base of what you need to create. And the process is the first step in, well, designing a process for a piece of software and then actually programming it, right? Now linking this to test, I'll have different questions and remarks on that. And let's start with the first question. Do we create test cases for the functional requirements? Well, who's the first to answer that? Do we actually create test cases for the functional requirements? Let's try. Yeah. Yes. Yes, of course. Why?
Well, we have to define the test cases before. Because that's really what the client wants, I guess.
Correct. True. Yeah. Can you define test cases for requirements? Let's try. Do I have an example for that? I'm not sure if I do. No. This may be interesting. Yeah. Okay. So this for instance is a requirement, right? Can we create a test case for that?
Well, yes, this is mainly to generic.
To a high level?
Yeah.
It misses something, right?
Yeah, the smart specification.
Yeah, it misses a specification. So, to go back to answering this question, no, you cannot. And you already answered why. We are missing way too many details. And if you attended the first lecture and the second lecture, then you would know that if you're not smart about the requirements, you just do not know what to create. And you definitely do not know what to test. And that's exactly the reason. Everybody has almost everybody has the instinct not to be clear about the requirements. And that's exactly the reason why many software projects go bad. Because everybody's instinct is saying, no, do not be smart about requirements. I mean, yeah.
Well, in my experience, I always specify my requirements smart immediately. Well, it takes
You do?
integration.
Great.
As far as it's possible, of course. But,
Yeah.
these integrations. And therefore, if it's smart, then you can test it. But you define requirements as a more high-level, functional.
Yeah, it's true. I'm using my definition of requirements. And my definition of requirements is still high over. It's not specific. We need specifications to make them specific. Kind of like, it says so in the name, right? Specification. So yeah, in my definitions of what I mean with requirements, and that's the reason why I highlighted the example over here, right? It's just a title. And if you're very lucky, you get a title and a description, but descriptions seldom are smart enough to be able to be used to create test cases. You really need this. So the answer is indeed no. But why? Well, because we do not have the right amount of detail to be able to create the test case. It's very true. So, but we're not finished yet. We continue. What part of the test case can be created from the specifications then? Can all of the three parts be? I'm not looking at you anymore because, well, I kind of like bothered you too much. So I'm looking at the rest of the audience over there at the back end. So, what part of the test case can be created from the specifications? Oh, which parts did we have? 3 of them. So the first was the initial state, start state, right? Correct. Second was script. Third was outcome, predicted outcome. So, what part of the test case can be created from the specifications?
Predicted outcome and
The start state, predicted outcome, so not the script.
You need more details for the script.
Exactly correct. Why is that? I'm looking at the front here. You didn't hear? God damn, you're not paying attention. Oh, you thought they were going to answer. Oh, sorry. So I'll repeat. They say you can create the start state, initial state, and you can create the predicted outcome, but you cannot create the script. Why is that? Yeah, I'll move to, right. So what
Because
is
the script requires you to kind of know something about the actual implementation, like the API.
Yeah. So in terms of that, what do you need?
Specification.
Yeah, oh sorry, yeah, but to be able to do the script.
Yeah.
Yeah, you need the process, you need the steps that the computer, yeah, the process at a high level, but also the low level. Correct. Clear for everyone, right? So the predicted end result and the start state. Now, another question. Does one specification have one predicted end result? Yes or no?
No.
No. Who said that? You said that. Right.
Yeah, I mean, with the deposit thing, like specifications that you like get a message or something, then the end result is either message or no message, which are two ends.
Yeah. Correct. Yeah. You can specify one or more results. Yes, exactly. What part of the test case, and I'm looking at, which part of the room will I be looking at now? This part over here. So what part of the test case can be created from the process? Come on, you know, right?
Script.
Yeah, the script. I mean, that's an easy answer. So let's continue. That's the only remaining part. Now, how does the logical data model come into this all? So why do you need that? Somewhere in the middle? What do you need the logical data model for? So the logical data model says this is the information in terms of entities and their attributes and their relationships.
I would say start state.
Start state. All right. More? Any end result. Yeah. Pretty good. Let's see if there's more. Oh, there's nothing more, but. Ooh. Yes. Sorry, I'll skip that away. Perhaps nobody saw it. So that's a logical data model. When you're actually testing, you need, of course, more than just a logical data model. So what do you need more?
Information model testing.
Yeah. Well read. I'll show you, of course, Raul. You already did that. So, well, the idea, of course, is it's just a logical data model. It does not actually say how the information is actually stored. Could be a file, could be in memory, it could be in a database. In most cases, it's a database currently. So, yeah. And if you're actually testing, you need to see if the end result has been produced, yes or no. And in that case, you need to kind of look into, well, for instance, the database to see if the end result was in fact produced. Yep. Now this is about the future of model-based testing, future of testing. We already saw a bit of that. I'm not going to go into too much detail, but I do know that at the time you're kind of like graduating, then I'm guessing that the adulthood of model-based testing will be better than it currently is. And if so, then it could provide a pretty good solution for the problem that we first had. So those 6 2 to the power 6 conditions. And this could do it. And the idea is that you create a test model, which is kind of like a definition of a precondition, a definition of the, or a specification of the initial state, the start state. And then you can have a system that kind of like automatically generates those test cases. And then have some sort of an adapter, and that adapter bombards the actual system with those test cases. And then some adapter again to kind of like collect the result. And then you have this big checker that says, okay, I have just created a test case. I of course know what the end result should be, and I'm just going to check if it's okay. And currently this already works pretty well, and it's a better approach, a faster approach for testing, and it covers much more because you can actually automatically create millions and millions of test cases just in a matter of seconds, and then bombard the system with it, which is of course a great performance test as well. But the problem is also that it's currently still hard to use. But this is kind of like, you know, this is going to be a big thing probably when you graduate. And it's the only thing I will tell you about it. As a matter of fact, we'll have an assignment. And because we have so much time, I may be able to even stay here and help you with that assignment. But the assignment will be the following. You will currently choose somebody else's system. Somebody you do not know. Because, well, if you're buddies, then you're too close to that person and you're kind of like have a tendency to ask him, how did you mean this? And why didn't you do that? And I kind of want to prevent that. I want to have, currently want to have a separation between a tester and a developer. Normally in Scrum, you would not have a separation between a developer and a tester. They would work together. However, they should still operate separately. Because if they're not working separately, then the developer will influence the tester in not being as structured as he should be. And a tester should be a pit bull. He should really try to mess up the work of the other, right? That's the job of the tester. Of course, he should not be a pit bull for the rest of the sprint because, well, I mean, you need to be structured, but you need to choose how many test cases you will create, and we will just run those test cases. But still, you will choose somebody else's spade-created system, no matter how finished it is, right? Then, based on the sheet 7, so that's the sheet that Bill just gave you, you will based on it, you need to create a solid set of test cases. As you can see, it also refers to the Cucumber project, but that's of course currently not applicable because, well, some do and some don't. So I really don't mind, as long as you use the approach start state, script, end result. Now, this is also a nice thing. You need to make a video of what you're testing. So you're not only need to create those test cases, but you have to try those test cases on the system that you test and make a video of that. Now, execute at least 5 of those test cases. And do not choose the first 5, but choose those that you think are very important, that really give an impression of the functionality. For instance, 2 years ago, somebody showed me all the 20 test cases regarding login and logout. I'm not interested in login and logout functionality. We know that works. So that's not really what I'm looking at. Perhaps 1 or 2, but well, that's about it. But the 5 that you choose should be those that really represent functionality that Bill is interested in. And you know where Bill is interested in, right? Okay, by creating those test cases, you will probably find extra ambiguities in your own specifications. I'm hoping for that. So, what I'm kind of like saying is, when you really start to structurally test somebody else's work, you should get some sort of an idea about, oh yeah, right, I didn't even figure that one out. Oh, let's fix my own work then. That's okay. As a matter of fact, if you come to those ambiguities, and there are, then you can solve them. If you come to those ambiguities and you cannot solve them because, well, you need Bill for that, then you need to Skype Bill. Right? All right. But note that Bill is a busy man. One big good thing about this is the deadline for this assignment will be before the week of my last lecture. And my last lecture will be, I believe, 6th of June. So we got a lot of time, right? But, well, as we have seen earlier, Bill can be sometimes tedious because he just entered this lecture and changed the requirements. Oh my God, what an awful man. All right. I would suggest, yeah, I would suggest that you start by choosing your work right now, and well, start with questions first. Right.
I've got nothing. How does that influence this?
You've got nothing, as in
You just...
you have not created those specifications yet, created the system yet.
Yeah.
Well, then you have nothing.
Yeah, that's it.
Yeah, that's an interesting test approach.
Can I test as well?
Yeah. You could. Yeah. Sure.
I have the same problem because I thought it was next week.
You thought that it was next week.
Because you said last week.
All right.
The
Yeah.
problem to
Yeah.
keep it through over 2 weeks.
Yes.
And I believe that some
Yeah.
other people with not in the
Yeah.
group has the same problem.
Okay. Well, you're a tester now, right? Yeah. Currently you're a tester, and you have a deadline yourself, right? Yeah. And you kind of like need to test the other one's work. So I would say that you're kind of like trying to push the person that is not yet has produced its work, and say, come on, give me the file. I want to try to test your system. And I'm sorry, but having an empty system will not do. You really, as a tester, you really need to try to test something that actually works. Yeah, you have your own deadlines. Yeah, one big sprint, but come on, give me something to test. You get it? Right. For you, that saying applies. He will probably haunt you to create something. And it needs to be finished earlier than the 6th of June. Much earlier, because he needs to have time to test it. It's kind of like a mini project.
So you said that if you find
Ambiguities, yes, it's a tough one.
So if you fix that in your own system, are you then, like, should you then send it again to the tester because you can test it on a new system, or is he supposed to just keep it testing on the first one you send?
I would say yes, and the answer is even bigger than that, but I won't tell you why. You have to figure that out for yourself.
Continuous integration.
Interesting. Your managers.
Yeah.
Yes. Those requirements and specifications are the basis of your contract. Ooh. Yes, indeed.
I can work on that.
All right. Any questions? No? If not, this is the utmost best opportunity to contact the ones whose system you're going to test.
Can you upload these slides?
I will send these, yes, of course. Yeah. It's good. As a matter of fact, I'll send these slides and the exact assignment tomorrow. However, for you that are already attending now, I would say choose your victim. You can do that right now. And I will still be Bill, and I will still be Steve, and I will still be Edwin for the next 20 minutes. Hi.
Ja, ik wil niet meer dingen
Stopping it now because everybody's working to test each other's system.